If you ever want to understand the limits of human intelligence, don't bother with philosophy or art. No, just look at the wind, or to use its more technical name, fluid dynamics. Now, every second, the air around us twists and folds and crashes into itself in patterns that are so endlessly complex that even our most powerful supercomputers take one look and go, nope. It's nature's way of reminding us that humans are clever, but not that clever. However, last week, Rolls-Royce, Quantinium, Riverlane, and the University of Edinburgh announced a new partnership to tackle this computational brick wall. Now, fluid dynamics is really just a fancy way of describing how liquids and gases behave when they smash into things. Think jet engines. Air gets sucked in, squeezed tight, mixed with fuel, ignited, and then blasted out the back, or as my old tutor used to say, suck, squeeze, bang, blow. And full disclosure, aviation doesn't usually keep me awake at night. But this particular story did make me think about something that I do deeply care about: Formula One. You see, modern Formula One isn't just about drivers or engines. It's a sport entirely defined by turbulence. Dirty air behind a car, vortices spinning under the floor, diffuser wake, tyre squirt, and even the violent porpoising that turned the 2022 season into a bruising physical experiment. Every single lap is basically a high speed negotiation with chaos. And I've been lucky enough to spend time inside team factories due to a previous role, and I've seen firsthand how they throw millions of pounds of supercomputing at this very problem. But even they are locked out by the math behind it all. And that's because the real physics of turbulent air is simply too big to compute, meaning that they're forced to rely on approximation, clever mathematical hacks, and educated guesswork. That's why partnerships like this one between Rolls-Royce and Quantinium matter so much. You know, quantum computing offers a genuine glimmer of hope. It flips the binary logic of classical computing on its head in favor of superposition, allowing qubits to represent 0, 1, or any fluid shimmering combination of the two simultaneously. Instead of calculating how one tiny pocket of air behaves and then moving to the next, a quantum computer could theoretically map the entire interconnected web of chaotic aerodynamic pressure all at once. It's a technology that's still fragile, messy, and likely decades away from true maturity, but the potential payoff is enormous. Teach computers to understand chaos, and suddenly you can design wings and floors and diffusers and cooling systems with perfect clarity. F1 teams will be able to model an entire car in full uncompromised physical fidelity, exploring aerodynamic concepts that today are literally impossible to simulate. And of course, it won't stop at the racetrack. Solve this for racing or jet engines, and you unlock radically efficient wind turbines or low emission cargo ships or industrial systems that we've only ever been able to sketch in science fiction. It's a quiet revolution powered not by steam, electricity, or silicon, but by the fundamental physics of the universe itself.